Yeah, actually, Vikas is to take it away this week. He demoed the serverless deployment on AWS last week, but he did not get a chance to do his actual go through the slide deck. So, Vikas, it's yours.
Yeah, thank
Oh,
you,
perfect,
Partha.
perfect.
Hi, everyone. Can you see my screen?
Not yet.
Not yet blank.
Oops. So,
And because I know that you had to hurry up a little bit last time demo, if you want to explain
yeah,
it a little
yeah,
bit better, you
I'll cover
can
it.
feel free to do that. Yeah.
Okay.
And guys, we also have a study group which is led by Vikas and Partha in the evening. I think you can find that study group of cloud computing in the Eventbrite. If you want to join that as well, please do so. Okay.
Okay.
Over to you, Vikas.
Yeah, can you see my screen now?
Yes, the slides we can see. Perfect.
Yes. So from last three sessions, Partha was delivering wonderful presentation about evaluation of cloud, microservices, and other cloud fundamental. Like it was a great explanation about how the microservices and API and service mesh works together. And of course, we need to know fundamentals of cloud before going to experience the cloud service in a real. Okay. So. Uh, Today, I'm going to cover further more about how the cloud works in nowadays, like who are the service providers, and I'll compare all cloud providers with each other. Most of we are going to cover AWS, Azure, and Google Cloud. So that's a market leader for now. So that's my focus, but I'll just talk a basic thing about other cloud providers, and we will see opportunity and challenges, and I'll give you uh, a tour of each each services, like how AWS dashboard works, and Azure. So let's begin. So in a market, Microsoft, Azure, AWS, and Google Cloud are three major leader, but there are a lot of cloud provider who are based in their own, you can say, um, in their own stream. Like suppose if I'll talk about Tencent Cloud, it is a leader in a game development service. So if you ever play like a PUBG or Call of Duty, it is a example of Tencent Cloud infrastructure. So it's a provider of, like, they can provide a architecture of Warzone games. Also, it has a great infrastructure of like live recording and media solutions, and also offer WeChat ecosystem. Uh, Alibaba Cloud is a big player in the China market, and also it has a span over in various Asian countries. It provide a business and modern retail growth solution, and it is one of the best way if you wanna enter in the China market, and also provide a free DDoS protection for web application. If I'll talk about Mirantis, uh, it's known as a container cloud because it's specifically focused on a microservices architecture. It's also provide a reliable Kubernetes engine and different type of Kubernetes cluster. And Oracle Cloud is based for on-premises users. So it provide lowest rate for fast connect service. So fast connect service is basically if you own your own data center, and if you want to expand it to cloud data centers. So fast connect service is a physical wired connection. It's a high speed with a minimum latency wire connection between your own data center to cloud data center. So if you want to expand your service, Oracle is a best for that. And it's also, if you are developing software based on SAP, then Oracle Cloud, maybe it's a cheapest option for you. And IBM Cloud is it's provide various services related analytics, AI, IoT, blockchain, logging and monitoring. It's also provide like IBM Cloud and PA solution, and it's also trusted by 47 Fortune 500 companies. So let's talk about more on Azure, AWS, and cloud now. So this was the trend on 2020 quarter two, and as you can see, Amazon covered almost 33% of the market shares, and other than that, Azure is like 18% and Google Cloud is 9%. This is the static by Statistica. And there are other cloud provider also, Alibaba Cloud, IBM, and Salesforce. So how the AWS started their services. So on March 10th, AWS first launched a simple storage service solution. So which is like, you can compare it to like a Dropbox, or you can say Google Drive, but AWS was the first one who provided it for public on March 2006. And then eventually it launched simple queue services, SQS, on July 13th. And on August 25, 2006, it launched EC2, which is Elastic Compute Cloud. And we use that service to create and define our virtual machines. Google Cloud started its first service on April 2008 by launching Google App Engine. And furthermore, on May 2010, it launched Google Cloud Storage. Microsoft Azure actually started the career actually started their services on October 2008 by announcing Windows Azure platform. But the thing is, it was for their internal use. But it launched on public on February 2010. It was commercially available at that time. So how the global cloud infrastructure looks like. So there are main three portion in this. So you heard about, like, if you are using cloud services, then you heard about a region and availability zones. So what are the regions? Regions are basically a logical geographical areas in which cloud provider data center reside, and each region is a separate geographical area. It's a logical. So it's and availability zone are isolated location within the data center region. So suppose if I'll talk about Canada Central region, so we should have more than 2 data centers in our region. Yeah. So that 2 data center call as availability zones. And as I said, each AZ is made of up to 1 or more data centers, and it has highly powered and cooling system, and also it has a great networking architecture. And on AWS, there is another term, it called edge location. So if you are planning to launch your web services or any web app, then the most important part is your user can use it with minimum latency. So edge location is basically, it's surrounded near major cities around the world, and it's used by CloudFront to distribute your content to end user to reduce the latency. It's like a front-end service for service we access, which are located in AWS Cloud. So suppose this is a Canada Central AWS Azure region, and there are 3 availability zones, and it has, as I said, it has uh, it powered, and it has a cooling system, and it has a great networking ability to connect with each other. And this is how AWS region looks like, AWS infrastructure looks like. So it has a logical region and availability zone, and this local zone you can compare as edge locations. So which are nearby the metro cities. You can think of Toronto or Los Angeles, New York. Yeah. So as of now, AWS has 24 logical region and 77 availability zone within those region. If I talk about Azure, it has 33 regions and 59 availability zones. And Google Cloud is also similar like AWS. It has 24 availability 24 regions and 73 availability zones. And Microsoft is surprisingly expanding their services. So as you can see, AWS is providing 184 services in total. It includes all of the service like S3, EC2. We will see in a demo that thing. Azure is providing 420 services, which is amazing. It has a vast use of services. If you wanna do any AI operation or machine learning or anything, you can do on Azure Cloud. And Google Cloud Platform is providing 93 services. So let's see about what are the pros and cons. So each of the leading vendors has a particular strength in and weaknesses that makes them a good choice of certain projects. So there are no perfect cloud or one size fits for all cloud solutions. So let's discuss some of our pros and cons. So Amazon's biggest strength is its dominance in the public cloud market. So it's been already 10 years for AWS. So part of the reason for this popularity is the massive scope of its operations, and AWS has a huge growing array of availability service, as well as the most comprehensive network and worldwide data centers. AWS is also most mature and enterprise ready provider with deepest capability of for governing large number of users and resources. And its weakness is related to cost structure, because AWS is regularly lower its prices or changing its prices. So it's a big deal in an enterprise, because it's difficult to understand the company's cost structure and to manage those costs effectively when running in a high volume of workload. So in general, however, there are cons more than outweighed by Amazon's strength, and organization of sizes continue to use AWS for a wide variety of workload. About Microsoft Azure, uh, it came late to the cloud, but it gave a jump start by essentially taking its own premises software like Windows Server, Office, SQL Server, SharePoint, and you can say Active Directory, .NET Solution, and also a big reason for Azure success is so many enterprises deploy Windows and other Microsoft software. So that's why Azure is tightly integrated with these other applications and enterprises that are use a lot of Microsoft software often. And this builds loyalty for existing Microsoft customer. Also, if you are already existing Microsoft enterprise customer, it gives a significant discount for services. And on the other part, some reports find that it's not a completely like enterprise ready platform, because many clients reported that the service enterprise feels less enterprise ready than the expected, given Microsoft long history as an enterprise vendor and customer side issue with the technical support and documentation and training. So it is basically not providing the best documentation for that service users. And Google Cloud Platform is has a strong capability of offering in containers, since Google developed the Kubernetes standards and that AWS and Azure now offering, but Google Cloud Platform is specialized in that thing. Also, GCP is specialized in a high compute offering like big data, analytics, machine learning, and it also offer a considerable scale and load balancing services. Google knows that data centers and fast Google knows for that data centers and fast response time. So if you are launching one VM in a Google Cloud and in Microsoft Azure, you will find a significant difference, because if you start a VM in Google Cloud, it will be up and running in within you can say 30 seconds, and in Microsoft Azure it takes a lot of time. It take about 3 to 5 minutes sometime. So yeah, and on the downside, Google is a distance like third in the market shares, but because of it doesn't have the traditional relationship with enterprise customer. However, it is quickly expanding, as we see in a previous slide that they are expanding their global infrastructure to cover more customers and more users. And clients typically choose the Google Cloud Platform as a secondary provider rather than a strategic provider, because GCP is increasingly chosen as strategic alternative to AWS or Azure by customer whose business compete with Amazon, and that are more open source centric or DevOps centric. So let's see what are the opportunities by using a cloud. So it's actually enables the service to be used without any understanding of their infrastructure, because if you know your requirement that you need to run like 10 GB of uh, you need to run a VM with consist of 10 GB of RAM and 500 GB of hard disk, then you just need to select the option. You don't need to do any like networking work or any infrastructure or any yeah any manageable work. So the cloud provider do everything for you. Also, it provide a massive scale. So if you want to scale your application to certain level, you can do that on a cloud platform. It also potentially lower the outlay expenses for startup companies, as they would no longer need to buy their own software or servers. They can just buy from the cloud provider, and they charge for only pay per use. Like if you wanna buy any license for your on-premises server, you need to pay upfront. But for the cloud, it's not the same thing. You just need to pay what you are using. Yeah. So as I said, cost would be by on-demand pricing. And vendors and service provider claim cost by establishing ongoing revenue streams. And data and service are stored remotely but accessible from anywhere in the world. So if you launch a VM in a US region, but you can access it from anywhere in the world. It also has an unlimited storage capacity because cloud computing offers virtually limitless storage for your application. And if your server might have 5 TB of hard drive, which is really small in compared to the hundreds of petabyte available in the cloud. It also has a lower compute cost because you don't need to run high powered and high priced computer to run cloud computing's web based application. You just need to configure based on your users. You also do not need to maintain the cooling and other facilities of the server. So let's see what are the challenges of the cloud. So use of the cloud computing means you are depending on others and their terms and services. And that could possibly limit the flexibility and innovation. And the other are likely like become the bigger internet companies like Google and IBM, who may monopolize by the market. And security also a big issue in the uh, cloud architecture because it is unclear how safe outsource data is when you are using this service ownership of the data. It is not always clear. There are also issues relating policy and access because you don't know what happen if the remote server goes down, and if the remote server goes down, then how will you access the files? So those are the major thing. Like if the whole data centers goes down, then you don't know what to do. So let's see the major service outage which happened in the past. So in December 24, 2012, AWS has an outage which caused a huge downtime for Netflix, and whole northeastern United States couldn't accessible Netflix services at that time. Also in 2016, AWS Sydney experienced an outage for server hours as a result of the thunderstorm, and the whole region causing a power outage to the data centers. So in 2019, US East 1, which I believe a Los Angeles data center, suffered from a power failure at a certain time, and the backup generator failed at 6 a.m. So according to AWS, this affected 7.5% of EC2 instance, and which is 1/10 of data center in one of the sixth availability zone in a US East 1. So US East 1 region has a sixth availability zone. It has a most availability zone in the AWS global infrastructure. So you can relate like 1/10 of uh, EC2 services were not accessible. So it means like it is hard to like after restoring power, a number of EBS volume and the file system of EC2 cloud server were permanently unrecoverable, and which cost huge for AWS. And one of the like Reddit was one of the affected company because of this. For Azure, if you see like in 2013, due to expiry of SSL certificate, Xbox Live and Xbox Music and video also affected. In 2018, due to cooling system failure. North Europe region experienced 11 hours of downtime, which is huge. And in 2018 also, like cooling failure in because of a lightning strike, and it brought down numerous service in a multiple region over 25 hours. So sometimes it is not the best thing, but these are the natural disasters. Some of these are natural disaster, and because of this, we might face like huge downtime. So let's see like how the dashboard looks like for each of the service. So give me a second. I need to replace my give me a second. I'm just setting up the.
I have Azure open if you want to click over and.
I'm unable to open the 1 second. Okay. And now. Okay. Can you see my Microsoft Azure? Okay.
Yeah, we can see that.
Okay, 1 second. Ooh. So I had enabled two-factor authentication. So give me a second. Okay. So this is how Microsoft Azure looks like, and you can see various services which are provided by Microsoft Azure. It's a virtual machine and app service. Virtual machine is basically a compute service which provide you different type of virtual machines for as per your uses. It has a service category. If you see all services, yeah, here is the thing. So these all are compute services for different users. This is a function app. It's like AWS Lambda, and this is a disk. It's a store. It's provide a hard drive for your virtual machines. So if you see networking services, it has a load balancers. I'm just showing you some of the most popular services. So this is the load balancer, firewall, and security groups. So security groups help you to minimize the traffic for your services. And you can just open like minimum ports which need to be accessible by other users. This storage service is kind of a object storage services, and maybe let's see AI and machine learning. So okay, yeah. Here is the IoT hub. You can create any IoT infrastructure by using these services. So, and it has a separate section for DevOps related things. So you can create a DevOps organizations and even API connections and some dev test labs. So it has a great affability of services. So let's see on AWS, as I'm more familiar on AWS, so I can talk more about these services. So Elastic Beanstalk is a kind of if you wanna run a web app or any kind of app, you just need to deploy your app on this thing, and it will be up and running. You don't need to care about the what infrastructure will be provided, and it will be for sure. Uh, it offer high availability and also high scalability. So these are the all service groups. So in a computer, you can see EC2, which is a similar like virtual machines, and then it has a Lambda. It's a same like ape engine, and it provides a serverless architecture. In a storage, S3 is a simple storage service, and EFS is Elastic File System. Storage gateway, and S3 Glacier is if you want to store your archive data for a long time for any governance and any audit use case, then S3 Glacier provide a lowest rate for storage. And these are the database that are provided by AWS. So some of them are like RDS service. Um, you can create any relational database. So just click on relational database, and you just need to provide the which provider you want, like Microsoft SQL or Oracle or PostgreSQL, and just need to do some of the configuration, and it will be up and running. DynamoDB, it's same like it's similar kind of a MongoDB. It's a NoSQL database, and these are the most critical part, which is networking. So on VPC, you can create your own virtual private network, and Route 53 is it's providing DNS services, kind of like if you wanna route your sorry
Sorry.
you wanna say something?
No, because I just inadvertent.
Okay, sorry. So Route 53 is a kind of a we can use for any web application. If you wanna create a route to the different virtual machine or on a different target, you can use the Route 53, and it also help in load balancing. API gateway, you can create a API. So which I showed you on a serverless architecture, but I'll repeat that again later. And these are the developer tools. These are amazing. Cloud9 is a IDE on the cloud. So if you wanna run IDE, IDE means like you can think of Visual Studio Code or a PyCharm. So you can create your own IDE on this Cloud9. So I just invoke one. I'll show you in some time. And code commit is kind of a repository, and artifact is kind of a JFrog. It store your build artifacts, and we have like many monitoring service also. Let me see. Okay, so here is the This is the monitoring service for your infrastructure. It's all in one. You can create your own dashboard to see like what is the status of the your servers. I don't have anything running currently, so that isn't available. But if I wanna see my previous logs, then yeah, it store all of the log. Yeah, you need to configure it while creating any kind of resources. So you can access the logs from CloudWatch, and it also gives you like what are the build duration and what is the like memory uses and init duration and how much memory it used. Okay, so
Vikas, can we look at the other cloud interface also?
yeah, like Google Cloud.
Yeah. Yes. Let's. I mean,
Mm-hmm.
want to cover all the clouds, so let's move on to the other cloud.
Okay, sure.
Yeah. But again, this is, as you know, Vikash, right? This session is the cloud computing fundamentals, right? So the
Yeah.
details we have, when you want to move on to the next step, give me like 2-3 minutes so that I can show to the team the plan that we have. Okay.
Okay, sure.
Sure.
And I guess Partha is more experienced on a Google Cloud. So do you have a Partha?
Yeah, I mean, I do have it open. If you want
Yeah.
me to go with that.
Yeah, because this is kind of a last slide, and I have some demo further, so I can move on the demo.
You did a serverless demo. Are you? There are other demos also planned. Is
Yeah,
it?
it's a like 5-minute demo if we have time.
Okay.
Okay,
So
so I just want to show them like how we can invoke a web application on Elastic Beanstalk.
okay.
Yeah.
What I'll do is I'll open the Google Cloud and then I'll give you control over the screen so that you can at that point request control and take over, and then you can navigate. Will that be okay? We'll try that.
Actually, I'm deploying onto AWS.
Okay. Now you want to do the demo now?
Yes, for
Okay.
just for 5 minutes.
Yeah, I think it's okay, guys, right? See, the intention of this particular session is to show what are all the different clouds and different services that are available. I think you have done that job, right? Obviously, this session is not for the details. Each one service you can take 6 hours of session, right? So
Yeah.
I think you're going on the right direction. So I would recommend that you continue with the demo.
Yeah.
And make sure that demo is covered, right? Last time we did a little bit.
Yeah.
You had to hurry up, right? So let's do the demo quickly.
Yeah. So last time I saw a demo for service-less architecture, and I posted a link on the chat for that. And this is demo for infrastructure-based architecture. So let's deploy a web app based on a Tomcat, and just need to upload my code. And this is Apache web app. Okay. So this web app is my code base, and just create the application, and AWS will take care of all infrastructure thing. So it's now, let's monitor the log. First of all, it's creating Amazon S3 bucket to store my data. It will take a few times. So let's go to S3 and check.
So what's happening is Elastic Beanstalk is actually a sort of deploy pipeline, which also stands up infrastructure.
Yes,
So
correct.
depending on what code you are providing, in this particular case, are you providing a web Java-based web
Yeah,
application?
Java-based web app. Yeah.
So obviously you need a web server and some storage to store your pages that you're serving up. So that's what is happening. The Elastic Beanstalk automatically looks at the code, parses it, and knows that it is a web application. So it builds a web application server or web server and storage, and then deploys the application, and it's automatically done for you. So
Yes. So it's actually assign a EC2 VM, and then it will install a Tomcat on it, and it will configure my code with that Tomcat. It will deploy it into web apps folder, and yeah, and it
okay.
also providing a different scalability and load balancing services. So yeah, so it's creating auto scaling group. So if like
So
for any reason, if my server goes down, it will create a new server automatically.
So this is what we are speaking of when we are talking of standing up a VM is simple. It's not as complicated. But when you come to enterprise concerns like what is the security, what is the high availability,
Yeah.
and so on, so this is automatically provided by this Elastic Beanstalk.
Yes.
This has happened to be a Java application, so you're standing up a Tomcat server. If this happened to be a Node.js application, a web service running on Node server, then you would have an a VM with npm installed on it running, and the application will be automatically started up and served up. So maybe it will use an Nginx or some such simple web server to give you the user interface.
Yeah.
Go ahead, Vikas.
Yeah. So it says my application is deployed successfully, and it has deployed a bunch of other services also. So let's see the flow. So first of all, it's create a Amazon S3 storage bucket to storing my data, and then it's created a security group, so which limits only port 80 to the specific instance. Okay, 1 second. So where are the logs? And I'll show you my application. It also gave us a URL to access it by public. Okay. Oh, it's down for some reason.
Okay, the important thing is that it's there.
Yeah.
There will be some errors which can be resolved. You can look at the logs.
Yeah.
You can triage it, find out what's wrong, and then make it run.
Yeah. Let's move on the other part then. You wanna take over, Partha?
What we will do is I will want to go into Google when I actually do a demo of something that we are going to stand up on Google.
Okay.
Same thing with the Azure Cloud also. So Kader wanted 3 minutes time to do introduce something and do some governance stuff. So Kader, you can take over. You proceed, and after you finish, I'll continue with I'll step into DevOps, and then during the DevOps, you'll do a demo.
Sure. Hey, what I wanted to really tell the team is, the session that you're going through right now, it's called as a cloud computing and DevOps fundamentals, right? So we are trying to basically learn the basics of cloud computing and DevOps fundamental in this session. The idea is not to learn everything. Then if you actually see, if you go down in the Eventbrite, if you see the other codeathons, right? So the next codeathon that's coming up on May 8th, it is build app with microservice architecture. So here you would actually learn a little bit more details on how to build an app using different microservice architecture. And I'm looking forward to Vikas or anyone in the team to contribute on this session, right? Then we have another session on the same cloud track. If you go down, there is something called as in August 7th, we are starting something called as a Docker and Kubernetes in action. So here you will try to learn more of Docker and Kubernetes. I know the topic is big, but within 6 hours, it will help you to establish the base that is required for you to do that, right? And then if you go down further, we have one more. Yeah.
I see the attendance screen only. Are you sharing? Yeah.
Yeah, I did. Maybe I did a wrong screen. Apologies. Let me quickly do that again. Can you see it now?
Yes.
Yeah, okay. So this is the Eventbrite screen that I was actually showing, right? So the program that you guys are going through now, it's called as a Cloud Computing and DevOps Fundamentals. Idea is to learn the basics, which is what is being taught by Vikas and Partha. This is really good, right? And we have totally 4 codeathons for cloud. Okay, this is the first one, which started on February 6th. Today is our 4th session, 2 more sessions to go. Then we have a second Codeathon session on the cloud. It's called as a build app with microservice architecture. We are still looking for, we want to see if any one Amazon or Azure experts can come and train in their product platform how to actually do this, right? And of course, if any of you have an experience and wanted to join them or you wanted to deliver the session, you're welcome. Remember, in Testoper, we learn to learn, train to learn, right? So we don't think about the quality of the program, but we think about the people coming and collaborating and learning from each other. That's what we really think about. So this is the second Codeathon program, build app with microservice architecture. Then the third Codeathon program on the cloud, it continues with the topic called Docker and Kubernetes in action. Then finally, it continues and ends the year with DevSecOps and cybersecurity. So these are all the 4 cloud-based Codeathon sessions that we have planned, and we will go one step after another to finish the year with all those 4 topics for the cloud. I just wanted to set the stage by sharing this with you all, that this particular session is just about the basics, and if you wanted to learn the additional details on respective cloud topics, you can join the future Codeathon sessions to learn. And outside of that, we have a number of other programs. I will not go through that now. You can always go to the LinkedIn and Eventbrite, and you can register for them. The 2 programs that I wanted to explicitly say, I don't know how many of you actually attended last time this artificial intelligence that was taught by Harsha, and he is actually going to take the session, right? And you should he's going to start from very basic, and if you don't know anything about artificial intelligence and things like that, right, then you basically take it from there. Okay, you can join that session and you can go from there. Then let me see quickly here, just a minute. I wanted to show one more, and the one more is we have an importance of AI in connected industries and automation. You might already see that I've been marketing this in our Testoper project group as well as the Codeathon group. This is our most flagship program, because most of the people that we try to bring into this program who can spread the news and then bring attendees for all other programs, right? Smaller programs like Codeathon and so on. So if you have not registered it, please register for this. These are the 2 programs that I sincerely say to do this. Okay, that's from my end. I will hand over it to Partha. I know it's 8 minutes.
Khader, I have one more thing. This is Abdul.
Yeah, Abdul.
Please, same thing, job portal, job channel, and Testoper.
Yes, guys. Yeah, okay, I'll do that for you. So team, once you are in the Microsoft Teams, right, we have 2 channels. One is the tech teaser, where we would like all of you, whichever news that you feel is the good news for the community to learn, please come and post it here. We would really appreciate it, because we want to increase a lot of collaboration in this platform. The more people start to collaborate in this platform outside of the event like this, the better we are. Okay. And then the second group that we have is, we really wanted to help our community people to succeed. So let's say, for example, if in my company, if I see some jobs that is relevant for our community, I come and post it here. And those who do not have job, they can come and see that I have posted. That means maybe, I might have some reference, or I might not have some reference if I copy and paste from somewhere else, right? So you can always reach out and apply for the jobs and things like that. So it comes within, all these responsibilities comes within. If you and me think that we wanted to help others, then we can get help also from others. So keep that in your mind. And it's not important that you just come for this session and go, but what's important is you actually contribute for your own benefit and contribute for the community. And that's what we are all about. Testoper community is all about, and that's what we need to do as a team together. Okay. Perfect. So anything, I think I did just open couple.
Yes, Khader, thank you very much.
Sure. I will stop here. I know that Partha, you have just 6 minutes. I don't know what you're going to cover in that, but I'll leave the floor to you. And then I will also leave you to close the session. Don't expect me to close it. Please close the session as well. Okay.
Okay. Thanks.
Sure.
Okay, my screen is visible.
Yes, Partha.
Okay. So where's my presentation? I actually wanted to start a presentation on DevOps, but since we don't have much time, I'll just go very quickly through what we want to do in DevOps. So, okay. These are the various DevOps areas that we have. I won't go into what is DevOps, and that we'll do in the next session. So a partial list of the areas is infrastructure as code is a very important DevOps area. So anybody who wants to learn DevOps has to know what is infrastructure as code and what is Terraform, what is Ansible, the two most important tools in it. There are also Chef, Puppet, and Salt. Those then you need to know what is code repositories. Definitely you need to know GitHub, GitLab, and Bitbucket. These three are the most important ones. CI/CD tools. This is a very small list of CI/CD tools. There are plenty of CI/CD tools, but you definitely need to know Jenkins, and you need to know what GitLab CI/CD does, and very importantly, a newer area is GitHub Actions. Containerization, you need to know Docker and Containerd, and orchestration, you need to Kubernetes and OpenShift. So what we're going to do is we're going to actually look at this demo of infrastructure as code, and what this is going to do is we are going to provision a Kubernetes service on an Azure on the Azure platform. Okay, so the whole code is in where did I put the code? So start opening up my screen. There you go. So in Testoper cloud computing Git repo, you got this particular cloud computing repo. We have got this Terraform provision AKS cluster, and the whole code is lying here. It is basically whatever is in this particular learn guide is what is there, and this guide is okay. Let's open it and just have a look what it says. So this is from HashiCorp, the people who give us Terraform, and they give you a complete tutorial on how to set up this whole thing. Of course, there are some changes to this in here. I don't put the credentials somewhere where, so if you look at this credentials, I've just put access. My credentials are on my laptop. These are credentials to access this. So let's get into the demo. This is my Azure portal. And if I look at resource groups, I have absolutely nothing in Azure now. This is I wanted to give a short intro into what is okay. This is what the code is in the repo. You got a cluster.tf. This is the main Terraform file. Credentials are here, but I don't put my credentials here. My credentials are elsewhere. I just source the credentials. I'll show that to you. And after the provisioning is done, the state is stored in a file called terraform.tf state, whether the plan worked, applied, destroyed, whatever. That's just a backup of those. And then Terraform TFVARs, I'm not using TFVARs here at all. That's why I just renamed the file to bypass, because I'm using my credentials and not this file. And the variables that this cluster, this deployment uses are in the variables.tf. So you can go and look at it, have a look at it, but we'll go jump into the demo immediately. So this is where my whole the same things are on my laptop. So this is the cluster.tf and so on. Hello.
But you want
Partha,
to you want to
Partha,
maximize this, and
there's
we
a
have
request for you to maximize your screen, please.
Okay, sure.
Yeah, thank you.
That's the Terraform. Sorry, the Terraform script. So all I need to do is in here is the creds are in one level up, and those are in creds.rc, and I will source that by saying source rc. Let us see what it contains. It contains something called app ID, which is the app ID that's going to that's already in Azure, and this is the password that it will be using. Okay, so to apply this, you use the Terraform commands. Terraform apply. And it will do a bunch of things. I'm going to while that's running, we look at the resource, the Azure console also to see what's happening there. So this is supposed to provision a full Kubernetes cluster on the Azure platform. So what Terraform Apply does is it tells you these are all the things that I'm going to do. Okay, these are all the things that I'm going to do. Do you want to perform these actions? And you have to give a yes if you want to perform. If this is run through a pipeline, you can actually auto approve this. There is a parameter that you can provide with the command Terraform Apply auto approve, and it'll automatically go without waiting for a yes reply from you. This is done. It'll start provisioning. It's going to take a few minutes. Let's run through the demo and then we'll stop. So it's going a few minutes beyond 11. So I'm looking at resource groups. So on my shell terminal, I'm seeing what is happening. It's creating Kubernetes cluster, still creating. It is, and slowly the resources are being set up. A Kubernetes first a resource group is created, then a Kubernetes cluster is created, and then nodes for the Kubernetes cluster are created. There's a master node and a worker node, and all that we'll see happening. The prereq to run this whole thing is you must have Terraform installed on your the system that you're working from. You must have a Google account, which has some credits in it so that you can actually deploy something in it. And you have to create a service principal. So if you look at this provisioning in a cluster, it tells you to prereqs. You might have kube control. If you want to interact with the cluster, you need kube control. Otherwise, you don't. This is important that you have to create an Active Directory service principal account. And the password and app ID and the password that we saw just now in the credentials file is this actually. So now cluster is forming. If I refresh the screen, what do I see? There. So you have resource groups have been created, various intermediate. You do have this one. This is the Cloud Watcher, and this is your actual resource group. And within the resource group, you have a network watcher. So here it is still creating. Terraform is very verbose in what it, I mean, not very verbose. You can actually have more verbose too, but this minimum verbosity is it will tell you, almost every 30 seconds it will keep on telling you what. So there, a Kubernetes cluster has been created now. That's your resource group. So boss sloth RG, that's what it's spat out here. Boss sloth RG is your resource group name, and boss sloth AKS is your. So if you go into this resource group, you have this AKS, Azure Kubernetes Service has been created. And within the service, you can see there's a node pool that has been created, and the node pool has actually two instances in there. If you go in and see that, you will see that Kubernetes service, network type, Kubernetes, and so on and so forth. So you have a private network created. A DNS service IP is this, and then there's a Docker bridge also, and you can then put a NAT service and a public IP router with a public IP and a NAT service on it, and associate this particular private IP space, the 10.0.0.6/16 space, with the NAT and the router, and you're up and running. So that's about it. Just wanted to show this, and that is related to the infrastructure as code part of DevOps. So this is, we just did the Terraform, how to use Terraform to create cloud resources as complex as a Kubernetes cluster. You can adjust the Terraform TF file to have any number of nodes you like. This is just a master node and a worker node. You can have multiple masters, multiple worker nodes, and you can do much more than that. You can set up secrets, you can set up namespaces, and you can then deploy applications onto the Kubernetes cluster too. Okay.
Yeah, I think it's good, Partha. I mean, good demo. Guys, this is a trailer, okay? Partha, I also wanted to tell you, I know that you wanted to cover a lot of things for the people to really help them out. But at the same time, this is a trailer, right? If you wanted to really know more and learn more on these details, Partha, you can always reach out to him. And he is there in the study group that happens on every Tuesday. He and Vikas is there. You wanted to learn a little bit more details about some part of the movie. Still, I don't believe that you can see the full movie, because full movie is you. You have to learn by yourself and have to have a continuous mindset to watch the full movie. But what you can see here is the cloud fundamentals, at least the session that we are going through. From my view, it is a trailer, and you wanted to see some of the scenes of the movie. You can go to the study group. You want to watch a full movie, you become a continuous learner and learn by yourself, right? So that's the way that I see it. And also kudos to Vikas and Partha as well, right? It's not that easy to, training is an art. And in our community, we don't really look for the professional trainers, right? And we don't really regard the quality of the training. And what we regard is the people like you and me come and teach and learn from each other. That's what we really focus on. And we are doing a great job from that point of view. Kudos to Vikas and Partha, and wonderful training. And I can tell this much, even though we do not look for the professional trainers, you both go beyond the professional trainers to train us these topics. Thanks a lot, Partha and Vikas. So if there is nothing, Partha, from your end, would you allow me to close the session for today?
Yeah, please go ahead. And please, people there is a Tuesday evening study group. If you have any questions, please join and ask. And I really encourage you to actually go and try this, download this code from here, cloud computing. So the serverless that Vikas demonstrated is also here. The code for this Terraform is also here. Go ahead, try it out. Yeah, go ahead, Kader.
Yeah, sure. I mean, allow me to close means closed. You just have to say closed. We are closed.
Yeah.
The
We
team
are
have a
closed.
wonderful week, and please do go as requested and register for our other programs. And we want to get as many people as possible into our meetup program, because the meetup program is where all the managers, directors, VPs, and all top people join. And if they know about us, and different people also who are working as an engineer know about us, they will spread the news, and our organization will organically grow. And we don't have money like other big organizations where we can put a lot of money for marketing. We run on zero money. We run on people, all of us together, right? So the only way that we can grow is through the organic way of growing. And the organic way of growing is each one of you spreading it to another 5, and another 5 spreading it to another 5, all the good work that we are doing together, and grow our community. And the final words again, please, if you don't have, if you have not registered, register it. And if you don't have a Microsoft Team accounts, join the WhatsApp group and send your first name, last name, and your email address. We will add you into Microsoft Teams. It is very, very important to collaborate before and after the event, not just attending this event for an hour and forgetting about it. That's not, is going to really help us to give back, right? If you want to really give back, we need to collaborate before and after, help each other, grow our skills, grow our career, grow our entrepreneurship and entrepreneurship aspirations. Having said that, I'll close this officially. Thanks, guys, for your patience. Again, 13 minutes over time. We always do that, and we need to learn better do next time. And the same thing happened in Testo for project last Friday. We'll make sure next time onwards, we'll try to keep up the time as much as that we can. Thanks a lot, guys. Have a wonderful evening. Wonderful day, wonderful evening, wonderful weekend. Bye-bye.
Thanks, Kader. Thank you, everyone.
Bye, everybody.
Bye.